Now that we've connected all of our devices to our test setup, we are now going to begin configuring our test settings. Here we have an example of the power map for the VC1902 platform using the values pulled from the Power Design Manager, as well as margin to stress test the device under test. For this example, we will only be using one rail. So we will right-click within the window, deselect all, and click on the rail we want to use. Then we will move on to our pass-fail settings for the sweep. Here we can see all the values that will be used for our pass-fail settings. Any of these values can be changed by double-clicking within the box, but for now, we will leave these as default. Now we configure our static load settings for the sweep. Here we will get a visual representation of what is going to happen using the settings below. By clicking any of the values, we can edit the value or the formula within. For this example, we're going to use steps of 25% rather than the default 5%, and use a duration of 5 seconds rather than the default 10 seconds. Finally, we'll move on to our dynamic settings for the sweep. All of the settings can be seen in the table below, similar to the static load. Any of these values can be edited by clicking on the value. For now, we're only going to change the duration formula from 1 second to 100 milliseconds. Now, we can go on to Run Test tab and begin the run. Now that our test is running, we can see above on the GUI that we're capturing the voltage and current waveforms. If we zoom out all the way, we can see the full 2.5 millisecond capture that the GUI is able to do. At any time, we can pause and zoom in on any axis to be able to see what's happening. If we press stop, we can stop the entire test, which then has to be restarted from the beginning. This is essential if a critical error is seen during the test. Now that we've completed our 118 tests, we're now going to view our results. Within the Reports tab, we can either view the results, create a detailed report, or export all of our data to CSV. Within the detailed report, a name is required at minimum, but we can also add a board serial number, a bench number, as well as display top, display base, overshoot, undershoot, and waveform. These boxes will add significant amounts to the PDF and much more time to generate, and so for now, we will leave it simple. For this one rail, we've generated 15 pages. Here's our welcome page, the table of contents, a summary of the pass, borderline, and fail. Borderline is anything within 10% of failing. Below that, we can see our tolerances for the rail. We can see our dynamic and static load settings. If we continue to scroll down, we can see the VCC int, our first rail, broken up into a dynamic and static load for pass, borderline, and fail. Continuing to scroll down, we can see more details for our dynamic analysis. We can see the 25, 50, and 75% graphed here. And below, we can see the table that corresponds with this. And within the table, anything white or gray is passing, anything orange is marginal, anything that is red is failing. Scrolling down, we get to our static data. Here, we can see our static data represented in a graph. Below that, we can see the table that corresponds with this data. If we decide we wanted to do a single test, we can go back to Run Test, go to Custom. Here we can set the test type for either static or dynamic. First we'll set it for static, and we can see our settings below. Here we have the current we'd like to use, as well as a preview of the current. If we press slam, the current will begin the slam. The GUI will only capture a 2.5 millisecond window of the slam. The slam is continuing until you press stop. If we change the test type to dynamic, we can see all the dynamic test settings below. And by pressing slam, we can get the data that we wish. Now that we've completed that testing, let us move on to a 3D plot using voltage, frequency, and duty cycle. Here we can see the data is generated in real time once we press run, and we have an index below letting us know if the slam was a pass, marginal, or fail. Thank you for your time, everyone, and I hope you enjoyed our demonstration.